Ice in the water, floating, because ice is less dense than water. Water, when it's frozen, is less dense than water when it's liquid. Now, most things are the other way around. If you put a piece of solid iron and you drop it in a pot of melted iron, it sinks to the bottom. Same thing with gold, with silver, with almost anything you care to name. But water, this unusual characteristic, is what keeps the ice on the top of the pond, helping all of the life within it survive. After all, if ice froze from the bottom, then every year all the fish, all the plants in any place where the temperature got below freezing for any sort of long time would die each year and have to be reseeded in the area. One of the interesting characteristics of water itself is it can be split in two pieces. It can go from being H2O to an OH and an H, a hydrogen atom and a hydroxide ion. So we got a hydrogen ion and a hydroxide ion. Now, water will split under a number of different circumstances, but you have heard of acids and bases. Now, acids are those things that have a lot of hydrogen ions, that lone H sitting out there with a negative charge, with a positive charge. Bases are those things with a lot of hydroxide ions out there. Now, the acid starts with A. Now, A comes before B, acid comes before base. One comes before two. The lower a number is on the pH scale, the more the more acidic it is. The higher a number is, the more basic it is, or more it is a base. So you've got acids and you've got bases. Now, a very strong acid will dissolve things. A very strong base will also dissolve and destroy things. In the middle is water that's been distilled, and that's at a 7. So the pH goes from 0 to 14. At the very lowest levels, it's an acid. A, remember, comes before B. 1 comes before 2. At the highest levels, it's a base. B comes after A. 14 comes after 0. And any chemical can be found somewhere on this balance of the pH level. Now, in terms of that, we also, what we find is that changes in pH can be very dangerous. Like in a human being, if your blood gets too basic, then you're going to die. If your blood gets too acidic, then you're going to die. So what your blood has within it is something called a buffer. Now, a buffer is something that's pretty neutral by itself, but when a strong acid or a strong base enters into where the buffer is, it sucks up all of the hydrogen ions in that strong acid and neutralizes it, so the pH goes up to a neutral level. The buffer is something that when a strong base invades, sucks up all of those hydroxide ions and brings the pH back down to a neutral level. And your blood is full of buffers so that the pH in your blood doesn't get too high or too low, because either way could be lethal. One of the reasons this is so important is in terms of our chemical reactions. Our body has tons of chemical reactions going on all the time. And the thing is that some chemical reactions absorb energy and some release energy. Now, a chemical reaction is just any type of an action between different chemicals, between different materials. Every chemical reaction, regardless of whether it absorbs energy or it releases energy, has an activation energy. It has a certain amount of energy it requires to get it started. It's kind of like if you're going to push a car. The car is stalled out, you ran out of gas, you got to push it to the gas station. You think about it, when you go to push it, you start pushing, it's really hard to move. And then as you keep pushing and it starts rolling along, it gets easier and easier to move. Well, think of that activation energy as that beginning push of getting the reaction started. And that's what this graph shows.